Here in this video, we are solving a problem that appeared in NEET 2025 from a chapter, from a concept of something like waves, particularly a concept of sound. Well, the problem is like this. A pipe at both ends open has a fundamental frequency F in the air. Now the pipe is dipped vertically in water drum to half of its length. What happens to its fundamental frequency now? So to understand this, we shall know what do you mean by pipe open at both ends and what is its fundamental frequencies. Let me go right from the basics and explain to you that how do we understand that, right? So let us consider a pipe. Pipe is supposed to be a thin pipe, but I am drawing a big one so that we can understand easily. See, this is one end open. This is another end open. This kind of a pipe is called something like open pipe. So when air starts flowing into the pipe, how does it happen? Is air enters into the pipe like this. Air enters into the pipe like this, and then after touching this surface, it will become like this. And then air entered from the other surface also goes like this. So this is how it is going to form waves in this, right? So how it is reflecting in this case, I am not explaining in this video, so that this video won't become lengthy. Please go into the waves chapter. There I have explained what happens with open pipes and closed pipes in detail. But now let me simply tell you that here there is something like an antinode is formed with a maximum displacement. Here a node is formed with a minimum displacement. Here there is another antinode is formed. So the entire length of the pipe in the most fundamental way of vibration, will have two antinodes at the tip of these two tips of these pipes. So if you look at the wave, actually this is how a wave is. This is moving in a forward direction. This is the formation of a stationary wave. Now it reflects back like this. This is node, this is node, this is node. So if you look at the thing, this is one wave, crust and trough. Length of that one wave is called wavelength lambda. But here this is an antinode, this is an antinode, or this is a node and this is a node. You can clearly see that between this node and node we have a distance half of this distance. So between node and node, or between antinode and antinode, there is a distance of lambda by 2. So the entire length is stretched as lambda by 2 in a fundamental mode of vibration or a basic mode of vibration. This is the least vibration it can happen. There could be another vibrations. I am not going into that in this place. Then lambda equal to 2L. I am talking about a pipe called open pipe. We know V equal to N lambda. Frequency N equal to V by lambda. N fundamental in this case is lambda fundamental in this case. V by 2L. So this is what he has given for you. It is having a frequency F, means he means to say that F is V by 2L. This is what is being said here in this problem. Now let's go to the second part of the problem. He said now it is now dipped vertically in water in a drum of water. So what happens when it is dipped in a drum of water is water with a half of its length. So if I draw the same pipe now, half of it is in water. This is not in air, this is in water, right? So the length, so this end is closed. The sound wave enters like this and reflects back like this in a most fundamental way. The first thing, the L closed that is available is, as half is dipped, L open by 2. So if you call this as L open, here there is only half of that. I call that as L here. In this case, now it will become automatically L by 2. So here there is a formation of node. Here there is a formation of antinode. So the distance between them is only between a node here and between an antinode here. Between a node and node, as I said, or antinode lambda by 2. Between the node and antinode, it is even half of it, because antinode is exactly in between the two nodes. So in this case, the value of that L closed, who is equal to L by 2, is lambda by 4. That implies L equal to lambda by 4, right? So what we can say, lambda into 2 equal to 4L. So lambda equal to 2L in this case. Now again we'll use the same formula, V equal to N lambda. V remains the same, N is enclosed, and lambda is lambda of this case. This case is 2L. So N closed of the closed pipe in a fundamental way is again V by 2L. Here also V by 2L, here also V by 2L. That means the new frequency, because you are dipping it, is not changed, and it's actually the same frequency of the open pipe itself. So this is how we have to handle open pipes and closed pipes. And the most important thing is to understand the concept, the story behind it, right? So the thing is, like, when the pipe is open, at both ends antinodes are formed. When the pipe is closed, at the closed end there is a formation of node, at the open end there is a formation of antinode. And for the length we are mapping basing on the distance between nodes and antinodes. So we can say this is a complete wave, forward wave. When it got an obstacle, it becomes backward, and there is a stationary wave is formed. At the ends, nodes. Here also node, here there is an antinode, here there is an antinode. So what we can see clearly, if you notice, is between these two, the distance is lambda, because it is a complete wave of crust and trough. Between node and node, or antinode and antinode, half of that, lambda by 2. Between antinode and node, even half of that, lambda by 4. If you once know that concept, and know the concept, like when it is dipped in water, one end behaves like a closed end. These things, if you understand, this is a very standard problem. So many times it came in the examination. It came again in NEET 2025, right? This is how we have to solve the problem. Thank you for watching.